Hello all. So today we'll have a brief introduction of the different standardization activities and the different international as well as Indian standards on environmental testing procedures. What exactly do we understand about environmental testing? Well, it has nothing to do with the climatic conditions, but it is one of the most crucial aspects when we are using the gadgets, the equipments, be it electrical or electronics. We all use mobile phones, laptops, and other electrical equipments as well. But do you know that the temperature conditions, the humidity conditions, the pressure conditions of the place where those equipments are being used has a very much crucial effect on that particular product. So today we are going to discuss on what are those aspects of environmental conditions that needs to be catered to, and how to assess whether the gadgets that we are using every day, be it electrical or electronics, will be okay in all temperate conditions, be it in any environmental condition. So as you can see, here it is mentioned as IS/IEC 60068 series. So this is the series of standards on environmental test procedures, which basically talks about what are the different types of criteria of those tests, how to perform those tests, and why those tests are important. Let us take a deep dive into this. So these environmental testing procedure standards ensures that the products perform reliably in real world conditions. If you see India holistically, you will find temperatures ranging from -2 degrees centigrade to +65 degrees centigrade across India. Now, it is very difficult to keep on changing products when I am moving, say, from Jammu and Kashmir to Kanyakumari. So, it is the same product that needs to comply to all the temperature possibilities, be it anywhere in the world, not only India. So what goes into environmental testing? Now we are talking about temperature, humidity. But do you know vibration, mechanical structures, vibration, mechanical shocks, pressure conditions also play a pivotal role in the proper functioning of that electrical and electronic product. So all these aspects gets covered under environmental testing. This particular series, IS/IEC 60068, provides a detailed guideline for assuring that my product is efficient, it is durable, it's safe, and it has great performance. This is the structure of the entire 60068 series of standards. It is classified broadly into 3 parts. First part is about guidance. It's a generic standard across different types of tests. Now, as I have explained, there are different types of environmental conditions through which the product needs to cater to. For example, there is temperature condition, there is humidity condition, there may be aspects of mold growth on the particular product, there are pressure conditions as well, and as well as there are mechanical conditions as well. So part 1 talks about the general guidance of all these products, how to perform the test, what should be the preconditioning when you are putting a particular device under test. Part 2 talks in detail about how a particular test needs to be performed. For example, if I want to test this remote and ascertain that whether this particular remote is going to work efficiently be whatever be the temperature, be it -2 degrees centigrade or +65 degrees centigrade, I have to put this remote through a series of tests. What are those tests? How to perform those tests? Part 2 gives us a detailed criteria of all those aspects. Now coming to part 3, what does part 3 tells us? Now I have done the preconditioning. I have subjected this remote to the different types of tests that it needs to go through to have efficient performance. Now what am I supposed to do after the test is done? How to provide a conclusion to the test? What are the documents that I need to prepare after the test is done? So part 3 provides this aspect of supporting documentation and guidance. Next we come to the, for example, if we are talking about the numerical value of a quantity. Like I said, in part 1, we generally give the general aspect of the environmental test procedures. One of those general aspects is defining a particular parameter. That is what is given in this slide of talking about a numerical value of a quantity. Now, if we take this aspect, there can be two cases. First, it can be expressed as a nominal value. For example, a temperature is generally given as a nominal value over here, like it can be written as 40 ± 2 degrees centigrade, or say 2 ± 0.5 seconds, right? If we go about relative humidity, it can be written as 93 + 2 - 3. So this gives an example of how you are going to write a particular value as a nominal one. Second, if we are giving a range, what does range mean? From something to something, from a lower value to a higher value, right? So here it gives the example, for example, 15 degrees centigrade to 35 degrees centigrade. This gives a range of value. So how to write a particular basic quantity, how to define it, how to do the preconditioning as per these values, all these are contained in part 1 of the standard. This was just a illustrative example of how part 1 talks of. Next we come to part 2. Here I will be explaining you one of the important tests. Now part 2 talks about different kinds of environmental tests. For example, cold test. Now if I go to Siberia, I am not going to change my mobile phone because my mobile phone should not stop working in the cold deserts of Siberia. Also, my mobile phone should not stop working, say, in the heat of Rajasthan. Hence, these environmental conditions are necessary to ascertain the proper functioning of my mobile phone, or say, be it any gadget or any equipment. So these are the different types of tests that are performed on the gadgets to ascertain their efficient performance. First is cold. It is generally written in the form of letters. These are mnemonics given to each of the tests. A is for cold test. B is for dry heat test. C is for damp heat test. It's a steady state test. D is for damp heat. Again, it's a cyclic test. E is for impact test, right? If something just falls on the ground, right? So the force with which it is impacted on, that is the impact test. Then comes test F, that is vibrational test. What happens if my product is subjected to effects of vibration? That talks about vibration test. G is about acceleration. And there are some other tests which are still to come. Hence we conclude with test J, that is the mole growth test. Sometimes it so happens that in the testing equipments, due to non-usability of that particular equipment for a very long time, mold starts growing. So that should not be the case, because that is going to harm the proper functioning of that equipment. So we need to perform the tests that are mentioned under test J to ascertain that even if I am leaving the product unused for a long time, it should not develop mold on the surface. So that is what is mold growth test talking about. Next we have test K, that is the corrosive atmospheric test. Generally the salt mist test. What happens if I go out to a seaside with my mobile phone or say my laptop? It should not stop functioning because of the effect of the salt mist that is there in the atmosphere of a seaside, right? So that is test K. Test L is dust and sand, like it should be free from the effects of dust as well as sand. M is air pressure, like it should function properly, be it high altitude or at a low altitude. N is again change of temperature, it should function properly even if it is encountering a change of temperature. Q is sealing test, R is water test. For example, there should not be any effect of rain, water or say mist even. These are some of the other tests, like S is for radiation test, test T is for effects of soldering, U is for robustness of terminations. See, like for example, this remote has different terminations where screws and other things are there. So that should not affect the functioning of this particular equipment. So this is all about test 2, like part 2, which I already talked of. This is what a test chamber looks like. In most of the cases we use this test chamber, be it cold test, dry heat test, damp heat test, steady state cyclic test, temperature change test, and this is what a testing chamber looks like from outside, and this is the internal view of a test chamber. So for example, this is the specimen. The specimen can be anything, say this remote. So I have to put this remote here after proper switching off of the element. Like I cannot keep a functioning mobile phone inside it, like it should not be in the on state. I have to switch it off and then put that particular device into testing. This is the hand pellet. Once I put it, I push it inside and then it goes inside. So these are the walls which are insulated by air. These are generally quite huge in structure, so that the test can be performed, and all these are mostly long duration tests. And this is what the inside of a test chamber looks like. So here you have the hot air is coming. This is the test area where I have put my device inside. This is where the cold air goes out. So once you go through the standards and get to know how these tests need to be done, you can better understand how this actually works inside. But maximum of this is automated, and this is where we need to just put our values and get our results. So these are the different types of tests. These have been mentioned here, like I was talking about solderability. You can see the solderability test here. Then some acoustic vibration test is also there. Part 2, section 65 is talking about the acoustic test. So these are different types of tests. Here you see the dust and sand test, part 2, section 68. So these are the different parts and sections of 60068 that is talking about the different types of environmental tests. One of the tests that we are going to take a deep dive into is the composite temperature or the humidity cyclic test. Now, why this test is done? It is done to determine the resistance of the specimens, like how much resistance it has, the device has to the deteriorative effects of high temperature or humid and the cold conditions. For example, this remote, if I am taking to a very cold place, this should have resistance to the effects of cold. So how much resistance it has, that can be calculated through this particular test. Now these are the descriptions of the test chamber. The test chamber we have already seen in the previous slides. This has just been noted here, the different parts and components of a test chamber. Then we need to do, before doing the test, one most important criteria that needs to be ascertained is preconditioning of the specimen which is going to be tested to ascertain the environmental factors. How you are going to ascertain the preconditioning? Some preconditioning criteria is already specified in part 1 as well as part 2 of 60068 standards. Here we are talking about the composite test. So in the composite test, these are the preconditionings that have been mentioned. Just let us have a look. First is assisted drying condition. During the assisted drying stage, the temperature should be 55 degrees centigrade plus 2 Kelvin. Now what are the units that are to be used are also specified. So while noting these units, while we are doing the documentation, it has to be in the same unit. We cannot use any other unit other than those specified here. Relative humidity should not be exceeding 20%. Duration should be 24 hours prior to the first damp heat cycle. Now for this test, it is required to have 10 such cycles. That is the prerequisite of the standard. So for having 10 different cyclic tests, the instrument should be ready 24 hours prior to the first cycle that is going to happen, right? So these are the criteria. Then what are the other conditions? After we do the drying, the specimen shall reach thermal stability at standard atmospheric conditions for testing unless it is specified. If some other values are specified, you have to confirm that the equipment that is under testing should be as per those values. If nothing has been specified, it should be standard atmospheric conditions. Next, the cooling rate. No specific rate is required for the composite test, but the rate shall not exceed 1 K per minute, right? So a maximum criteria has been set here. So before doing the test, I have to ascertain that all these conditions are met. Once all these conditions are met, we will go straight to testing the product. This is how we get the output data from the data logger that is attached to the test chamber wherein we are performing the composite test. So this is what it looks like. So these are just values plotted across the x and the y axis. So this is the y axis talking about temperature here, and this is relative humidity, and here you have the preconditioning parameters. Initial measurements. So what happens after we do the preconditioning? After the preconditioning is done, the specimen shall be introduced into the humidity chamber. Like I showed you in the diagram of the test chamber, the subject under test has to be in the switched off mode, right? So that is written, it has to be in the switched off mode. It has to be in the ready for use test state. That is also very important. And mounted in the normal orientation. I should not keep my remote like this. This is the normal orientation of the remote. That is how I am going to place it on the hand pellet and push it inside the chamber, the testing chamber, right? So once this is put inside the testing chamber, I have to ascertain that there are 10 cycles, temperature or humidity cycles. Each cycle will be of 24-hour duration. So from here, what do we understand? First, it's a long duration test, right? Because it's going to cross a day. Second, how many days are involved? 24 hours for 10 cycles. So 240 hours test, right? So almost 10 days minimum. That is the duration of testing for the composite test. So now you understand how rigorous is the testing for all the products that you are using today, be it your earphones, your laptops, your television sets and everything, right? So this is the final cycle. Once everything is done, the measurements are taken. How will you take the measurements? It is written in part 3 of 60068. There are prescribed formats for documentation of these tests. You have to follow those, write those results in the particular format that is provided in part 3, and get to a conclusion that whether the device that you have just tested is okay to perform under any environmental condition. Right? So this is part 3, which gives us information about the background of the family of tests as well as gives supporting documentation. So these are all the standards under part 3 which we just talked about. We took up one important standard, that is composite test. You can go through all these different parts of 60068 as well as different sections of 60068 part 2 and part 3 and understand and dive deep into how we ascertain the environmental conditions are met by your devices. So thank you all. I hope I could help you in understanding the environmental test procedures as per IS IEC 60068. Thank you.